Hello. So in the previous class, we talked about the scientific method. So in this lecture, I would like to review ourselves about scientific method and go over a couple of examples and confirm that we got this idea. Well, in my definition, the scientific method is a systematic approach to any problem that you're facing or trying to solve. And also it's more productive and satisfying than the other approaches to solving problems. So if you do any troubleshooting in this way, your life will be easy and more planned and productive. And the definition that you see on the screen is the textbook version of definition. So people can define this scientific method in different ways. But basically what's our approach is a systematic way of solving problems. So the scientific method is an empirical method of acquiring knowledge that has characterized the development of science since at least the 17th century. It involves careful observation, applying rigorous skepticism about what is observed, given the cognitive assumption can distort how one interprets the observation. All right, so let's look at another example. So if you remember, we talked about solving the problem regarding the coffee machine the other day. So you worked in the groups and we try to confirm our idea about solving that problem. It's a simple problem, but we learn like how to solve that in step-by-step procedure regards with the scientific method. Well, so let's say there's another problem. So there's a problem in your car. So it's not a start. Right? So the observation is that you see the car won't start. Then the question is, why won't the car start? Right? Then you're going to make a hypothesis. Oh, the car battery is dead. Right? So that's one way of thinking the problem, where the problem is. So the car battery is dead. Then we're going to do a prediction. Let's give it a jump start. Right? So that might solve the problem. So the test would be, we try to do the jump start to the car. Then the result would be either yes or no. So it might be solve the problem. Then there's no issue, so we solve the problem. But if the jump start does start the car, then the hypothesis is supported. So there's no need to go back and do something else. But literally, if you want to review the process, then you can try it again and propose a new hypothesis. Then let's say the result is the jump start fails to start the car, then the hypothesis is not supported. So we have to go back and reverse the procedure. So we have to start from the hypothesis like in this picture. So you go back to the hypothesis and think about a different source of error in the car not to start. Right? So that is the systematic way of solving problems. But I have seen on the roads, like when the car is broke down, people start and trying to jump on it and try to close the doors really hard. Sometimes it will solve the problem, but that's not the scientific approach of it. We just being panic and we're trying to solve the problem rigorously. So we are behaving a little different than what we do. Anyway, so if you, as you are a science student, you can use the scientific method to solve problems in your life. All right, so let's think about another observation. So think about the sky. So certain as the sunrise. So every day we see the sun rises in the east and the sets in the west, right? So the day is always followed by a night and the night is always followed by a day. That's a good statement, isn't it? And it's also a true story, right? So our ancestors would have made this observation of the natural world. We can appreciate it emotionally and discuss this logically. So whether this observation is real, is it valid everywhere on the earth, on the universe? So so let's look at whether we can apply this one into ourselves and can we make it a true statement for the physical world. All right. So in that case, the observation come to play a big role in scientific method. So the science, in sciences, the word observe means actually experiencing something for yourself. So basically you have to see that. Right, so that is an observation. So you are seeing it. That's my observation. Then when everyone who repeats an observation experience the same thing, the observation is said to be reproducible, and it's become a part of science. So if most people or most places, if the observation is valid, then it is a reproducible observation. So when we are doing scientific research, or if you are in a PhD program or a research program, then we are not just trying an experiment for one time and make it a law or a theory or a confirmation or do a publication. We don't do that. We wait and we try to do the experiment again and again, and we make it confirmed and make it reproducible, and we are confirming that it is reproducible, so it can be published or make it a scientific statement, right? So basically, observation need to be reproducible. So and we are not reporting any fake observation. We cannot report a fake observation in a scientific article. It can be fake news, but never publish something that's fake. All right, so let's look at this question. So which of the following statements is an observation of the natural world? So there are no prime numbers that have 0 for a last digit. Is that an observation? It's a mathematical statement, right? Then Galileo was the greatest scientist. That's your opinion. The US Naval Observatory says that the moon rose at 6:52 p.m. yesterday. So that's a report, right? So the Naval Observatory says that. That is not our observation. Then I saw the moon rise at 6:52 p.m. yesterday. All right, that is an observation, right? So that's our own observation. So we can report this as an observation. So from among these, the answer D, I saw moon rises at 6:52 p.m. yesterday, is a natural observation, or the observation of the natural world. All right, so can we observe that the sun rises in the east and sets in the west every 24 hours everywhere on Earth? That's a good question, right? So is it true? So if you have traveled to some other parts of the Earth, then you might have observed that these times are changing. So 24 hours a day, 12 hours of daytime, 12 hours of nighttime is not true at every place on the Earth, and also not every, along the year, it might change, right? So let's look at one example. So this is a sun graph for Murmansk. So let me take you to another view of this graph. All right, so let me take you there in really quick. All right, so on this website where you can check the sunrise, sunset, and daylight times. So let's look at the city. So this is a really interesting city for me. It's Murmansk, Russia, and it's in the, I literally want to visit this city in the wintertime and also in the summertime. So let's see why it is. So as you see here on this website, you can read all the details, like what is the sun direction, sun's altitude, sun's distance. So we are not worrying about these things. So let's look at what we are really concentrate on this point. So this is the location. So we are looking at a city located somewhere here, right, in Russia. Well, so as you see here, this is the 2020 sun graph for Murmansk. Here, as you see, this light blue color represents the daytime. So if you go to somewhere in June, what do you see? The nighttime, not for this day. So they don't have a nighttime in the month of June or July, somewhere here, right? And the astronomical twilight, not for this day. Then let's see, the daylight. So it's 24 hours daylight. So in that city in June 12th, on June 12th, they have 24 hours daylight. So there's no sunset at all, right? And let's look at sometime in December or January. So what happened there? So in December, if you go all the way to December 28th, let's get back. Right, so let's hold it there. So as you see, there's no daylight for this day. So it's no daylight, but they do have nighttime of 13 hours in total, and astronomical twilight and nautical twilight and civil twilight. So there's a bunch of these lights in there, but 13 hours of full nighttime, and there's no daylight like 12 o'clock in the noon time. There's nothing, right? So, okay, let's go back to our slides again. So I need to go to my PowerPoint slide here. Want to go there and see other cities, you may do that. So visit this website listed on the PowerPoint slide, click on it and it will take you to that website, and you can change the city or the country that you would like to see for this, the daylight graph. Anyway, so as you notice here, from this city, Murmansk, Russia, so on June 21st, they have full day sunlight, 24 hours sunlight, right? Anyway, so when you are reporting something scientifically, then, for example, I saw sunrises at this time yesterday. So you can make this statement a little bit more in detail and be scientific, and it's make valid for everywhere on the earth, right? So important factors of reporting an observation. So to reproduce an observation, you need to know all of the important circumstances of the observation. So the observation that sun rises in the east and sets in the west every 24 hours, we would say that the observation must be made at latitude less than 66.56 degrees north of the equator. So Murmansk is at about 69 degrees north latitude, and it is the large city within the Arctic Circle. So that's why we notice that it's in the summer months, they are getting 24 hours of daylight, right? So the daily rising and setting of the sun happens only south of the Arctic Circle and the north of the Antarctic Circle. So if you look at this Earth globe, then you see like this is the Arctic Circle, that's 66.33 north degrees, and this is the Antarctic Circle, that's 66.33 degrees south. So in between the Antarctic Circle and the Arctic Circle, we can see sunrises and sunsets within the day, within the 24 hours period. But if you go beyond, higher in the passing the Arctic Circle to the north, or the passing the Antarctic Circle to the south, then it's sometimes some days the people lives there will not observe sunsets at all, or they don't see sunrises at all. So it depends on where you're observing and what time of the year. So your observation, when you are presenting it scientifically, then you need to be very specific about your reporting your observation. So for example, like you said, like I saw sunrises 6:52 p.m. yesterday. You need to add more details, like, oh, I saw the sunrises at from east at 6:52 p.m. on August 23rd at this time, and my latitude is this and that. Right? So you need to be more specific about the location, about the time, and what you have observed. All right, so let's do some practice problems. So please answer the questions below on TopHat page. Thank you. I'll see you in the next video. Next lecture.